All right. Hello, my name is Zachary Wisti. Here with me, I have Jennifer Lowe and Clifton Boswell. Today we're going to be talking about cooling systems and steam power plants. So there are three different cooling systems we're going to be talking about today. We're going to be talking about once through, recirculating, and dry cooling. The picture on the right shows the different types of cycles and steam power plants.
The once-through cooling system is one of three methods used at power plants worldwide. It is known for its efficiency and its impact on the environment. Approximately 36% of all cooling in power plants use the recirculation method. The process includes taking water from a large natural source like lakes, rivers, and oceans and circulating it through the condenser. It is then discharged back into the environment. The abundance of water from the natural sources allows the once-through method to have a high efficiency. There are regulations regarding the water that is being taken in as well as removed. The once-through method has several positive aspects because they put power plants next to large bodies of water. There is an abundance of cooling water. They also are more cost efficient because the water does not have to be reheated or cooled down after being used. This makes them the most efficient cooling system there is. One of the negatives of the once-through method is the damage to the environment. After the water is used to cool the plant, it gets put back into the body of water where it came from. This can be detrimental to plants and animals. The temperature of the water can also have an impact on the cooling. In 2010, TVA had to reduce power at its Browns Ferry location to 50% to keep river water temperatures below 32 at a cost of $50 million to customers.
Next is recirculating. Next is recirculating. Recirculating is steam that passes through the condenser due to lack of a big water source. Cooling methods include cooling towers and on-site water sources such as ponds and streams. Cooling mechanisms mainly work through evaporation. Cooling towers evaporate up to 5% of the flow. Recirculating systems work by returning cold water to the condenser, and 3 to 5% of the water consumption requires continuous replacement. Some of the pros and cons of recirculating are: the pros is you have very good water conservation, good on the environment, big environmental impact, high thermal efficiencies, very versatile, and reduces visual impact. Some of the cons is it is a bit more expensive, so increased costs. The energy consumption is greater than some other cooling systems. The water quality concerns, sometimes the ponds and streams can get kind of dirty and that can cause problems. The overall plant efficiency is lower, and it uses more land, so that also increases cost.
So next is dry cooling. What is dry cooling? Dry cooling is using air to cool the condenser instead of water. There are two types, direct and indirect. Direct dry cooling is using strictly just air to cool, and indirect cooling is using a small reservoir, and not pulling directly from a water source. So this saves water and it just recirculates through the reservoir. The advantages of dry cooling is there's less water consumption. In direct dry cooling, there's no water consumption, and in indirect, there's a very small amount of water consumption. The disadvantages of dry cooling is there's more energy, higher cost, and lower efficiency. Lower efficiency due to the cooling rate of air versus water. And there's some plants use hybrid systems where in hot times of the year they use wet cooling, and in cold times of the year they use dry cooling, so they adapt to the changes of the temperatures. There's engineering in cooling systems. As we all know, the engineering design process, first you need to identify a problem. Once you identify a problem, you can run an analysis to see different aspects of solving this problem, and after your analysis you can run calculations to try and solve this problem, and then you also come up with a solution to this problem. And once you have everything running and everything in place, you can then make improvements on that design and that situation.
Here's one of the cooling equations we came across while looking through some case studies. This equation mainly is for heat dissipation throughout the cooling tanks. And here you can see it uses mass flow rate, the mass flow rate of water in the dry air, and the change in temperature within that cooling tower.
There's a case study based in Texas where they retrofitted existing coal and natural gas power plants with alternative cooling systems, either recirculating or dry cooling. Using an assessment tool, they estimated annual reductions in water and cost per gallons of water saved. Retrofitting all coal plants with dry cooling systems resulted in a substantial reduction in water withdrawals at a cost of roughly 68 cents per gallon of water saved. These reductions in water withdrawals that result from retrofitting the cooling systems at the NGCC plants are smaller but significant nonetheless. Once their systems retrofitting to dry cool systems achieve significantly more water savings per monetary investment than recirculating systems, making the same transition.
And here are our sources that we use.